Hello and good day, Sci folks. I'm back for another episode of Fun and Learning. Join me as we explore, discover, and enjoy life through science. Be ready with your modules, your notes, and everything you need for this learning episode. Are you ready? All right. This is Teacher MJ, and this is DepEd TV. In our last episode, we talked about work and how it is related to energy. We also talked about the first type of energy, which is potential energy. Today, learning continues as we discuss kinetic energy. Before we start, let's have a quick drill to test what you remember from last time. Answer the following questions. I know you can do this. Let's go! Blank is the capacity to do work. What is your answer? Right! Energy. It is an abstract idea related to energy. This is done when a force makes an object move in the same direction as it is exerted. What do you think is the answer? Great! The answer is work. What is the unit for work and energy? Did you get it right this time? Let's see. The correct answer is joule. It is the energy stored in an object which is based on its position, arrangement, or state. What is your answer? Yes, potential energy. If the work done on an object is equal to 10 joules, how much energy is gained by the object? What do you think is the answer? Very good. The answer is still 10 joules because 1 joule of work is equal to 1 joule of energy. Did you get it all correct? Awesome! I hope that you will also learn much from today's episode. With no further ado, let's do this! What is kinetic energy? When we talk about kinetic energy, we refer to the energy of a moving body or object. It comes from the Greek word kinetikos, which means moving. What did you observe? What do these have in common? Right, they are all in motion. With that being said, we can say that these have kinetic energy. Kinetic energy can be computed using this formula, where Ke is the kinetic energy in joule, m is the object's mass in kilogram, and v is the object's velocity in meter per second. The unit we use for kinetic energy is joule, same with the unit we use for potential energy and work. From this formula, the kinetic energy of an object depends on its mass and velocity. What do you think will happen to the kinetic energy of an object if its mass is doubled, but the velocity remains the same? The kinetic energy of an object will also be doubled. How about if the speed is doubled, but the mass remains the same? The kinetic energy of an object increases 4 times. This means that the greater the mass, the greater the kinetic energy, and the faster the speed, the higher the kinetic energy as well. To understand that, let's try solving. 2 trucks with masses of 5,000 kilograms and 10,000 kilograms respectively travel at the same velocity of 3 meters per second. Find the kinetic energy of each truck. How are we gonna do it? First, let's write down the given. Truck 1 has a mass of 5,000 kilograms and a velocity of 3 meters per second. Truck 2 has a mass of 10,000 kilograms and also with 3 meters per second velocity. Let's find the kinetic energy of truck 1 first. First, let's write the formula. That is KE equals 1/2 times mass and the square of the velocity. Next, we substitute the given values. 5,000 kilograms for the mass and 3 meters per second for the velocity. Then we square 3 meters per second. We get 9 meters squared per second squared. We then multiply that to the value of the mass at 5,000 kilograms, which will give us 45,000 kilograms meters squared per second squared. Lastly, we multiply that to 1/2, and we get 22,500 kilograms meters squared per second squared, or 22,500 joules. Now, for the second truck, we do the same process. We put 10,000 kilograms for the mass and 3 meters per second for the velocity. We get 9 meters squared per second squared after squaring the velocity. We multiply that with the mass at 10,000 kilograms, which gives us 90,000 kilograms meters squared per second squared. We multiply that again with 1/2, and that will bring us down to 45,000 kilograms meters squared per second squared, or 45,000 joules. To compare, truck 1 has a kinetic energy of 22,500 joules, and truck 2 with a kinetic energy of 45,000 joules. Any observation? Right, the kinetic energy was doubled. Why? As we said earlier, if the mass is doubled but the velocity is the same, the kinetic energy will also be doubled. Did you get it? Let's have another one, but this time, I'll give you time to do it on your own. A car with a mass of 2,500 kilograms traveled from a distance at 2 meters per second and traveled back to its starting point at 4 meters per second. What is the kinetic energy of the car going and returning? Your time starts now. Done? Take a look at this and check if you got it right. The kinetic energy of the car going is 5,000 joules and 20,000 joules kinetic energy when it returned. The kinetic energy of the car when it traveled at 2 meters per second increased 4 times when it traveled at 4 meters per second. The kinetic energy increases 4 times when the velocity is doubled and the mass is constant or the same. In this activity, you should remember that if the mass is doubled and the velocity is constant, the kinetic energy is doubled. Meanwhile, if the velocity is doubled and the mass is constant, the kinetic energy increases 4 times. Now that we already know about potential energy and kinetic energy, how they are solved, and the factors affecting these energies, let's try to discover how these two energies are related with each other. Let's do the psi experiment. One of the best ways to show the relationship of potential energy and kinetic energy is by throwing an object upwards. Take a look at this. To be able to understand this, remember the formula for potential energy and kinetic energy. Potential energy is equal to mass times acceleration due to gravity times height. And kinetic energy is equal to 1/2 times mass times velocity squared. Now let's go back to the ball. As the ball rises after being thrown upwards, its potential energy increases and its kinetic energy decreases. Why? It's because as it goes up, the height of its displacement increases, and that means there is a greater value in the formula PE equals mgh. The kinetic energy decreases because the velocity of the ball as it goes up decreases, which also means there is a lesser value of V in the formula KE equals 1/2 mv squared. When the ball reaches the maximum height it can reach, the potential energy gained by the ball also reaches its maximum value. That's why it stops for a short period of time before it goes down. The moment the ball stops, the kinetic energy is equal to 0. After reaching its maximum height and stopping at a short period of time, the ball then descends due to gravity. This time, the potential energy decreases and the kinetic energy increases. The height of the displacement of the ball decreases, which means that there is now a lesser value of height in the equation PE equals mgh. And its velocity increases, which means there is now a greater value of velocity in the equation KE equals 1/2 mv squared. It's fun, isn't it? I hope that you learned a lot. For us to know that, get ready for a test to see how much you learned about this week's lesson. Write your answers and see how many correct answers you'll get. Ready? Great! Here we go! The following situations demonstrate potential energy except A. A rolling stone at the seashore. B. A child at the top of a slide. C. A car parked at the top of a hill. Or D. River water at the top of a waterfall. A. A rolling stone at the seashore. The potential energy is the energy an object has due to its A. Acceleration. B. Motion. C. Position. Or D, velocity? C, position. The following conditions exhibit kinetic energy except A, water inside a glass. B, rolling stone from the hill. C, running athlete on the field. Or D, dancing kids in the living room of the house. A, water inside a glass. Which of the following quantities, when doubled, has the greatest effect on the amount of kinetic energy? A, mass. B, size. C, velocity. Or D, weight? C, velocity. If a green ball is higher from the ground than a yellow ball and both have the same mass, which ball has more potential energy? A, green ball. B, yellow ball. C, both has the same potential energy. Or D, both has the same kinetic energy. A, green ball. Congratulations for going through this week, Sci folks. I hope you're all learning a lot from me. Catch our next episode next week and you'll be in for a lot of learning surprises. This is your teacher MJ, your partner in exploring, discovering, and enjoying life. This is DepEd TV. Keep safe everyone, enjoy the weekend.